Thank you, Nate. Good afternoon, everybody. My name is Alex Beeson. I am one of our MEP applications engineers here at CAD Technology Center, and it's great to have all of you back who have joined us before, and great for those of you who have not joined us. What we're going to take a look at today are a couple of the out-of-the-box Revit families that really, in my opinion, have some pretty big problems with them in regards to functionality. And we're going to just look at how to make them more functional and kind of some of the processes that I had used in troubleshooting them and what I have done to fix these families. And this is going to be a fairly brief webinar today, and it's also going to be fairly introductory level, I should say. We're not going to dive too terribly deep. I want to keep it nice and simple for you and just kind of show you what you can do to take these families and make them something that you can actually use. And I actually will be at Midwest University coming up in March here. I will be doing a class on this same topic. And at that class, I will definitely be diving in much deeper into these same families and some more families and getting to the parameter level and injecting shared parameters in these families and mapping those parameters and bringing these families to a fully functional level within your template. And what I'd like to do after Midwest U is then come back and take some of that and probably do another one of these webinars with that deeper level look at these families. So like I said, we're going to take a look at a couple out-of-the-box families, discuss the issues that keep them from working properly, and we will discuss how to fix these issues and demonstrate the functionality that can be gained by fixing these families. So the first family that I want to look at here is the inline pump family that you get in Revit out of the box. I'm sure some of you are familiar with this family, and I'm sure some of you are also familiar with just really a lot of the general shortcomings, unfortunately, that we get with a lot of the out-of-the-box content in Revit as far as us MEP folks are concerned. And in my eyes, this inline pump is about as good an example as there is just how kind of bad this family is, or I should say how bad these families can be. And this is the in particular, this is our inline family, pump family that I'm talking about right there. So if we look at this family in plan view already, you can just kind of see that this family does not look right. It doesn't look clean. It looks like it might not be placed on the pipe true, I would say, or it looks like it might be tilted to one angle or the other just because of these offset circles here. And importantly, we're getting these odd transitions on either side of the pump, which don't look terribly bad in plan view, but if you've ever seen this family in section, you will know that these transitions are much worse than they appear to be in plan view. So now we're looking at that same inline pump in a section view, and we can see that we've got some very big problems with how this family is inserting into our pipe and what it is causing our pipe system to do to compensate for the poor insertion of this family. So we've got these very odd, completely unrealistic pipe transitions that Revit is creating to allow for this pump to be inserted into the pipe. And if we look at this, what we can see is happening is the insertion point of this pump is actually happening at the top of the pump here, which brings us to another issue with this pump, is that should actually be the bottom of the pump. This pump is coming in upside down as well. So yeah, if we look, we'll see that the top point in this section of that pump is lining up directly with the center point of our pump, or excuse me, our pipe, which certainly is not what we want out of this pump. So I'm going to go ahead and select this pump and dive into our family editor. And from here, we're going to take a look at what it would be that we would want to do to fix these issues with the pump, namely the insertion point issue, um, the kind of overall unclean look of the pump in plan, and finally the fact that the pump is coming in inverted or upside down. So the first thing I'm going to do here is go to one of our elevation views. And we can see, I'm going to go ahead and hide those dimensions, just give us a little better view of what's going on here. And in my research in this family, I found that I tried a number of things to try to fix the insertion point issue. And the first thing I'm going to do here is just grab our reference level and kind of drag it off to the side here so we can have a cleaner look at the family geometry itself and our reference planes. And also what I'm going to do is grab, there's a center reference plane here that's a little bit hidden in the geometry, so I'm just going to extend the extents of that reference plane so we can see a little more clearly. Now, in my research, some of the things that I did was to see did it matter if these reference planes were set to is reference, or if they were set to not a reference, or if they were set to center, or if they're set to top, bottom, so forth. And I found that that really wasn't the solution we were looking for. And what you're going to find with a lot of these out-of-the-box families is, unfortunately, a lot of these reference planes don't have names, so it's really hard to try to discern what the intent of some of these reference planes, these families, are for. If you've ever heard me or probably anybody else talk about family creation at CAD Technology Center, we very much push the idea that every reference plane should have a name. If it's worth being in your project, if it's worth being in your family, it should have a name. So it's a little disappointing that that is not the case in this out-of-the-box family. So what another thing I looked at is did it matter if these reference planes were pinned or if they were not pinned? And again, that did not have any effect on the insertion point of this family. In the end, what it ended up being, the problem is that this reference level is dictating where that family is going to insert into your project or into your pipe. So we can see that this reference level indeed is lining up right with that bottom point of our pump in this case, or in plan, it would be the top point of our pump since it's inverted. So what we need to do then is go ahead and unpin these two reference planes, and then we're going to align our family, all the geometry and all of we're going to align this reference level to this center reference plane here that's right at the center of our connectors. So I will go ahead and do my align command, and I will click on my reference plane, and then I will click on this, I will click on our reference level, and then I will click on this reference plane, and then I will go ahead and I'll lock this reference plane to our reference level. And we know that we did this properly because we can see that the reference level itself did not change elevation or offset. That did not move. We actually relocated the family in relation to that reference level. So now if I go ahead and load this family back into the project, I will overwrite the existing one. And I'm going to go back to my plan view here. There we go, hydronic piping. And now if I place that pump right now onto this pipe, here I'm going to bring up my section again so we can see this while it's happening. And now when I place this pump onto our pipe, we'll see that it is correctly inserting in regards to the insertion height of that pump. So again, what we did to fix the insertion issue that the previous version of our pump was exhibiting is we went ahead and aligned our center reference plane to the reference level within the family. And now that I've done that, I'm going to go ahead and pin these reference planes back down as well that were previously pinned down. So that takes care of that issue. If I go back to our plan view though, we're going to see that it still just kind of looks sloppy. This, to me, this just looks like there's something wrong with this pump. It wasn't inserted properly. It's not on the pipe properly. I don't know. It just doesn't look good to me. So again, in my research in how to fix this family, I found it's really pretty simple. If we go to the reference level floor plan and look at this family in plan view in the family editor, we can see that the issue isn't that it's not inserting properly on the pipe. It's just that it's kind of built to look funny. There's these different circular extrusions that just aren't lined up, and we can see that what is causing that is these 1/4 inch dimensional offsets here. So what I'm going to do is I'm going to go ahead and click on my reference plane here, unlock that dimension, then I'll click on my reference plane again so I can edit that dimension. I'm going to set that to 0, line that up, and then I'll lock that dimension back. And I'll do the same for this dimension over here, our horizontal dimension. I will unlock it, and I'll click on the reference plane again so I can edit that dimension. I'll set it to 0 and go ahead and lock that dimension again. And you may have noticed that when I did that, it also offset our discharge outlet so that again is in line with our inlet intake inlet, which again in my eyes is just going to make this family look better, look more correct. So I'll go ahead and load this back into the project, overwrite the existing version once again. And now when I place another instance of this family, we should see that it simply looks better, looks more clean, looks more professional. And there we are. We've got a nice clean look to the circular geometry. And even more important to me, we don't have this really strange looking, completely unrealistic transition here. This is never going to happen. We don't want to see that in our model, and now we're not seeing that anymore. So finally, we have the problem with our family that it simply is coming into our project upside down. We could insert all these pumps that we wanted to and use our little rotate family function if we wanted to get our family so that it was inserted properly as far as inversion is concerned. But we don't want to do that. We want to know why it's not coming in properly and how we fix that. So let's go ahead and look at our family once again. Oops. And we can see in the family itself, this family is correct. This family is actually coming into the project correctly, but then when it places, the family is inverting itself. So again, if I go ahead and if you watch when I place this pump, let's go up to this piece of pipe here where there's a little more room. When I place it, you can see that the family actually relocates itself, and that is the inversion occurring. So see, it's moving about half the family length over to one side or the other. In trying to figure out how to fix this, I went through lots of steps trying to figure out what the issue would be. Again, if any of you have ever had any family training with myself or CTC, I'm sure you've heard us talk about how reference planes in Revit actually have a polarity to them. So it's kind of like your Cartesian coordinates, where on your horizontal X plane there's a positive above and a negative below. That's exactly how reference planes behave in Revit. Um, and actually, so the reason I bring this up is if we draw our reference planes from right to left when we're creating them, we will have a positive property to the top and a negative property to the bottom. Whereas if we create those reference planes from left to right, that negative property will actually be on the top and the positive property will be on the bottom, where that process becomes inverted depending on which direction these reference planes are created in. And that applies to vertical reference planes as well. So I studied this family and to try to determine if that was the case. Are these reference planes simply drawn what would be the incorrect direction, causing this family to come in inverted? And the way that I could check that is if I give a name to any of these reference planes, when I then click on this reference plane, you will see the name appear on one side or the other, and what is dictating which end of that reference plane that the name will appear on is the direction in which it was drawn. So again, I'll go ahead and give this reference plane a name, and we can see that all these two reference planes, at least, were both created from one direction to the other in the very same manner. And I went and looked at every one of these reference planes in this family, and they were all created consistently, with all of their names on either the right end or the top end. And importantly, I was looking at another out-of-the-box inline pump family that works properly, and I was comparing the two, and the reference planes in both of these families were created exactly the same. So this turned out to not be a problem with the reference planes. I thought that it might have something to do with the what sort of references our reference planes had assigned to them, or where our origin was located at. But again, that did not prove to be the solution to this particular problem. I had even gone as far as disassembling all of these extrusions and these reference planes and kind of building it in reverse on the other side, just to see if that was even possible, kind of to see how much work it might be, and mostly because I just could not figure out how to fix this issue. But as it turns out, that's a lot of work, and I would not recommend anybody do that, and I'm not gonna have you suffer through watching me do that right now. And fortunately, as it turns out, I did find the solution to this problem, and it was incredibly simple. And I'm going to show you that right now. So what the problem with this family was, I'm going to go to a 3D view here of the family. It simply has to do with which of the two pipe connectors was assigned as the primary. And in our case, our left intake connector is assigned as the primary, whereas our right output or discharge connector is not assigned as the primary. So I'm going to go ahead and select our discharge connector, click on reassign primary, and you can see that when I do that, we get this crosshair. This crosshair designates which connector is assigned as your primary connector in the family. In this case, our discharge connector is now assigned as our primary pipe connector. So now when I load this back into the project, again, I'm going to overwrite the existing version. we don't see the already placed families change in any manner. This isn't going to affect the ones that we've already placed, but I'm just going to go ahead and delete one of these pumps here so we have a little more room. Oh, and this is another problem that always bothered me with having that offset on the two connectors is now our pipe is offset and we can't easily reattach it. But we fixed that. So now I've got some room to place that pump. I'm going to go ahead and place it on our pipe here. And we should see that it will come in correct or not inverted. And if we look in my section view over to the left here, indeed, that pump is now coming in correctly. Although we do have a little minor offset here. So I'll have to go back into the family and just make sure that everything is lined up properly. And it looks like it should be. Let's see where that's coming in. Go back to my other elevation here. Try to get a look at exactly what's going on. Well, we'll go ahead and move on from there. We would want to dig around a little further in the family and just ensure that our reference level indeed is aligned to that center reference plane and make sure that there's nothing else dictating the location of this center reference plane, such as some one of these dimensions or something of that sort. And really, this kind of brings us back to one of my first points in this conversation is it's really, really important to make sure that you label your reference planes when you're creating families and also to label your dimensions when you're creating these families because as it stands, I'm looking at all these reference planes and all these dimensions and it's hard for me to tell exactly what's going on. So just for future family building purposes, keep that in mind. So that's kind of my discussion on this pump for now, at least. From here, I want to move on to another family. We're going to take a look at the outdoor air handling unit horizontal family. So I will go up to my mechanical roof plan here. And here's our family that I'm talking about. And what the problem that I have run into with this family, or what I want to discuss about this family, is just the lack of flow propagation in this family out of the box. So if I click on this family, we can see what sort of flow it's reading off of our system. So I'll go ahead and click on this family and I'll look over in our properties here and we can see that our supply air outlet is reading 3200 CFM. And if I look at this piece of duct leading right in, or excuse me, coming right out of our air handling unit, we can see that appears to be true. We're reading 3200 CFM off that piece of duct coming directly out of our air handling unit. Now, if we look at our return air inlet flow, this is telling us that we've got 1000 CFM coming into this air handling unit. And I know that's not true. I know I can tell from two different sources right in my project here. Number one, our piece of duct coming right or leading right into the air handling unit is telling us that, whoa, there's negative 2,000 CFM that is supposed to be going into this air handling unit, where I see that and I think I find that doubtful. I don't think that that is true. Um, but more importantly, if I go and look at the system itself that this air handling unit is serving, I know that I've got one plenum inlet coming back. It's going up our shaft here, coming back around and into our air handling unit, and I know that I have got 3,000 CFM coming into this plenum. What I've done here actually is created a kind of a dummy diffuser that you can't see, but that I can assign CFM value to, just so that I can actually have a CFM value attached to this return duct here that's a plenum intake. So one thing I can do is I can go ahead and detach this return duct from our air handling unit to kind of see, check the validity of this number here, that negative 2,000. So I will do that. I'm going to go ahead and split this piece of duct a few times, and then go ahead and delete this portion so we can sever that duct from the air handling unit. And indeed, I can see that now this piece of duct is reading the correct 3,000 CFM from our return air system in this project that is connected to this air handling unit. So this kind of leads us into our second of two problems. Not only is this air handling unit telling us, giving us an incorrect airflow as a property, the return air inlet flow property for the air handling unit, but it's also pushing out an incorrect airflow to our return duct that's attached to it. So again, I'm going to go ahead and edit this air handling unit family. And we're going to take a look at some of the connector configurations of this family. So I'm going to look at this supply air connector, and we'll look at the properties of that connector. I can see that the flow configuration is calculated. I can see that the flow direction is set to out, and I can see that the system classification is set to supply air, and that all seems to be correct to me. So if I look at the return air connector, we can see that the flow configuration is set to preset. The flow direction is set to in, and our system classification is actually supply air, which that certainly is not correct. This should be our return air connector. This is where our return air is coming back to our air handling unit. So what I'm going to do is first I'm going to change the flow configuration from preset to calculated. I'm going to go ahead and leave flow direction set to in, and I'm going to change the system classification from supply air to return air. I'm going to go ahead and load this family back into the project. And now we can see that at the very least our CFM that is being displayed on this ductwork here is correct. It's no longer that negative 2,000. But if I go ahead and click on this air handling unit here, we can see that our supply air outlet flow is 3,200. Our supply air inlet, which is actually this connector right here, our return connector, is set to negative 3,000, and our return air inlet flow is set to 1,000. So that's all correct, really, other than the verbiage behind these connectors as far as our parameters. So the last thing I might want to do here is click on my return air connector, and instead of, and I'm going to go over to the properties and click on the associate parameter button over here on our flow parameter. And instead of associating the flow of our return air connector to a supplier inlet flow, I'm going to go ahead and set that to return air inlet flow and hit OK. And then on this top connector here, which I suppose would be our outdoor air connector, since we're not actually dealing with any outdoor air right now, I'm just going to go ahead and disassociate that parameter altogether. So again, I'll go ahead and load this back into our project, overwrite the existing version, and now we should see that our return air value that is coming into this air handling unit is both correct and also assigned to our return air inlet flow.